All right, we're group 49. We're going to talk to you about kinetic energy. What is kinetic energy? It is the energy of motion, an object that has motion, whether it's vertical or horizontal. The formula for kinetic energy is Ke equals 1/2 mv squared, where m is the mass in kilograms, and v is the speed of an object.
A rocket of mass of 15,000 kilograms accelerates at 220 meters per second squared for 29 seconds of initial speed of 5,200 meters per second. And you're trying to solve for velocity, so how fast would the rocket be traveling for 29 seconds? So we're going to use an equation where acceleration equals velocity minus initial speed all over time. We're going to solve for v, where v minus u equals at. So we multiply t on both sides. So we're going to plus u on both sides. So we're going to be left with v equals at plus u. And now we can plug in all our numbers and solve for v. So we're going to have v equals acceleration, which is equal to 220 meters per second, times time, which is 29 seconds, plus u, which is 5,200 meters per second, which we get velocity, which is 11,580 meters per second.
We're going to look at how much kinetic energy the rocket has gained. So we're going to start off with our kinetic energy formula, which is 1/2 mv squared. And we're given the initial velocity is 5,200. So the initial kinetic energy is 1/2 times the mass, which we know is 1,500, times the velocity, which is 5,200 squared. And we know the final kinetic energy is the formula once again, 1/2 the mass, which is still the same, 1,500, and the final velocity, which we calculated in part A, which is 11,580 squared. And to find the difference, we're going to subtract the final kinetic energy minus the initial is 1.006 or times 10 to the 12 minus the initial kinetic energy, which is 2.028 10 to the 11. So once you subtract that to find the total kinetic energy gained, you get 8.032 times 10 to the 11 joules. And that's your final answer.